So you're a Unity developer, right? You know how easy it is to just drag a button onto the screen. But what about a UI that has to juggle menus, inventories, and a dozen different screen sizes without completely falling apart? Yeah, that's where things get tricky. In this explainer, we're going to dig into how to architect a Unity UI system that's actually built to scale.
And this quote, man, it just hits the nail on the head, doesn't it? It's one thing to get some buttons and health bars on the screen. It's a whole other challenge to build a system that can grow with your game instead of becoming this slow, buggy mess. That's the art form we're going to get into today.
You know, as your project gets bigger, you'll find yourself fighting a war on 3 fronts. So we're going to frame this whole discussion around defeating these 3 main enemies that are always trying to tear down your UI: a performance monster, a rigid layout, and a tangled nightmare of code.
Okay, our first enemy is the re-render monster, or what a lot of devs call Draw Call Bloat. And this thing is sneaky. Imagine your entire UI as one giant painting. Now, what if you want to change one tiny detail, like a number on a timer ticking down? A poorly built UI forces Unity to repaint the entire canvas, every single frame. That is a massive waste of resources, and it's pretty much guaranteed to tank your frame rate.
So how do we fight this monster? Well, we stop thinking of our UI as one giant canvas, like you see on the left there. That's just asking for trouble. Instead, we divide and conquer. By splitting our UI into these specialized canvases, like you see on the right, we isolate the parts that change all the time from the parts that are totally static. This is absolutely the key to minimizing those expensive rebuilds.
This multi-layered architecture is our secret weapon. You have a static canvas for things that literally never change. Think backgrounds, frames, that kind of stuff. Then you've got a dynamic canvas for all your HUD elements that are constantly updating. And finally, an overlay canvas for things like menus and pop-ups that appear on top of everything. The result, when your health bar updates, only that small dynamic canvas has to rebuild, which saves a ton of processing power.
All right, enemy number 2, the rigid rectangle. Or, as we all know it, resolution fragmentation. Come on, we don't live in a 16:9 world anymore. We've got ultra-wide phones, we've got tablets, we've got devices with camera notches and weird cutouts. If your UI is rigid and built with fixed positions, it's going to look broken on most of them. The answer is to build what you could call an elastic UI, and that means no more positioning things with fixed pixel coordinates. That's just a recipe for disaster. Instead, we use Unity's amazing anchoring system to pin elements to the corners or the edges of the screen. And for modern phones, a pretty simple script can read the device's safe area to make sure your UI isn't getting awkwardly hidden behind a camera notch. And now for our third, and I'd argue most dangerous enemy: spaghetti code. This happens when your UI code and your gameplay logic get so tangled up that changing one little thing accidentally breaks 10 other things you didn't even know were connected. It makes adding new features, or even just fixing a bug, absolutely terrifying. If you see this line of code in your project, that is a major red flag. This is the very definition of what we call tight coupling. Your player script is now directly dependent on a specific object named health bar existing in your scene. What happens if a designer renames it or moves it? The whole game breaks. It's incredibly brittle. The elegant solution here is a classic design pattern called the observer pattern. Here's the core idea, and it's brilliant. Your player script shouldn't even know the UI exists. Seriously. When the player's health changes, it just broadcasts an event, kind of like shouting into the void, "Hey, my health is now 80. The UI is just listening for that specific message, and when it hears it, it updates itself. This completely decouples the two systems. You can change or even replace the entire UI without ever touching a single line of game logic.
Okay, we've defeated our 3 main enemies. Now, let's talk about future-proofing our system. Here are a few quick, high-impact tips to make sure your UI is ready for launch day and for whatever comes after. 3 quick micro-optimizations. First, use a sprite atlas. This groups all your UI images together so Unity can draw them in a single pass, which is way faster. Second, turn off raycast target on anything that isn't clickable. Your background doesn't need to check for mouse clicks, right? And third, if you use layout groups to position things, disable them after they've done their initial job. It'll save you some CPU cycles every frame.
Planning to launch globally? Awesome! But your UI needs to be ready to handle different languages. The word play in English is a much longer word in German, for example. So, 2 rules. 1, always use Text Mesh Pro. Just do it. It keeps text sharp and scalable. 2. Use content size fitters so your buttons can actually grow to fit the text inside them. But be careful, they can have a performance cost, so use them where you need them.
So after all that, defeating our enemies, optimizing for the future, what's the single most important lesson? Well, it all really comes down to a fundamental shift in your mindset.
And this is it. This is the core philosophy. Your UI is not one giant monolithic beast. It's a collection of independent, reusable plugin modules. Your health bar is a module. Your inventory is a module. When adding a new feature feels like just plugging in a new component instead of performing open-heart surgery on your code base, that's when you know you've got it right.
This modular way of thinking is just so powerful. It leads to code that's cleaner, more performant, and so much easier to maintain in the long run. So I'll leave you with this question to think about. Now that you see your UI as a collection of modules, what other part of your game, your audio system, your AI, maybe even your player controller, could really benefit from escaping that monolith? Thanks for tuning in.